Hi, I'm Rachna Bhattacharya, 50MS 151.
Hi, this is Fomi Mandal, 15MS 183.
Hi, this is Maithili Datta, 15MS 184.
And guys, we are here to discuss on the impact of climate changes
on water resources of the Himalayan region of Nepal. The water resources system is very sensitive to climate change. Climate change has an impact on important natural phenomena as precipitation, food, and the water supply in rivers. They, in turn, directly or indirectly affect factors as fundamental as biodiversity, food production, health, and power generation. The assessment of these impacts is very essential for an efficient, effective, and sustainable planning of water resources. Besides, water is getting increasingly scarce. Hence, the planners and managers concerned need to be aware of the impacts of climate change on water resources. At first, we will see the general impact of climate change on water resources. Then we will discuss the special case of Himalayan region in Nepal and some solutions and suggestions for given problems. The first and most visible effect of climate change is the rise in temperature, which itself is the major cause of many other changes. A great proportion of total precipitation appears to be falling as rain than before. Snowmelt begins earlier and winter is shorter. This affects river regimes, natural hazards, water supplies, and people's livelihoods and infrastructure. Another impact is the retreat of glaciers. Studies predict that in the coming decades, many glaciers will retreat, while smaller glaciers may disappear altogether. Retreating glaciers can destabilize surrounding slopes and may give rise to catastrophic landslides, which can dam streams and sometimes lead to outbreak floods. Excessive meltwaters, often in combination with liquid precipitation, may trigger flash floods and debris flows. The effects of climatic change are of tremendous importance to the often densely populated lowland regions that depend on mountain water for their domestic, agricultural, and industrial needs. Also, permafrost areas will be sensitive to degradation with climate warming. Recent studies show that the extent of permafrost is shrinking. This has altered the hydrological cycle, vegetation composition, and carbon dioxide and methane fluxes that appear linked to permafrost degradation. Climate change involves perhaps more seriously change in the frequency and magnitude of extreme weather events. There has been an increase in the frequency of high-intensity rainfall, often leading to flash floods and landslides. In the eastern and central Himalayas, glacial melt associated with climate change has led to the formation of glacial lakes behind terminal moraines, many of which are potentially dangerous.
Now we will discuss the impact of climate change on the Himalayan region in Nepal. Precipitation pattern and trend. The climate in the KRB is mainly influenced by the monsoonal system, physiography of the region and westerlies. The summer monsoon, which originates from the Indian Ocean, is the main cause of precipitation in Nepal, and as the KRB lies in the western part of Nepal, its influence is weaker than in eastern part of Nepal. On the basis of agroecological zones, precipitation in the mountains of the KRB is increasing, while in other regions it is decreasing, and it is higher in hills and trans-Himalayan regions. During the monsoon season, the precipitation trend is found to be increasing over the mountain region, with a decreasing trend in other parts. As the summer monsoon is the main rainy season, and such characteristics with increasing precipitation trend may cause more floods in the monsoon season, subsequently affecting the downstream region. The unique topography of the basin may be the cause for a lack of uniform trend. More number of stations are showing significantly decreasing trend than increasing in all the season. Likewise, Nepal also suggested lack of clear trend for the precipitation in the Koshi River basin of eastern Nepal. Temperature. The average maximum temperature of the basin is 25 degrees C, while the average minimum temperature is only 13 degrees C. In the basin, temperature starts to increase from the last week of December or the first week of January and reaches at maximum in mid-June. and then gradually decreases. Similarly, the temperature gradually decreases from south towards the north as the altitude increases. It is as high as 40 degrees C in the Terai during the month of June, while it is as low as -14 degrees C in the mountain region during January. On the basis of available data, the temperature variation in the KRB depicts that the maximum temperature is increasing at a faster rate 0.05 degree per year than the minimum temperature is 0.01 degree C per year. The increasing temperature may have different implications and affect all major components of hydrological systems, including precipitation pattern change, alteration of soil moisture and evapotranspiration rates, and shrinking in the overall glacier mass, providing short-term annual increases in meltwater contribution to downstream river flows.
Hey guys, I'm here to conclude whatever my friend Rachna and Maitri has discussed. Nepal lies in the central part of Great Himalayan Range and the KRV region lies in the western part of Nepal but was not considered well in the previous research. This research contributes to the understanding and interpretation of the hydroclimatic variability. Along with the contribution to knowledge and information about the basin and its social importance, this research has contributed to the application of scientific tools and methods in the remote and topographically challenging Himalayan basin. The result of this study showed that the average precipitation in the basin is decreasing by 4.91 mm per year with around 10% during the year 1981 to 2012, and both maximum and minimum temperatures are increasing. The rate of increase is greater for the maximum temperature, that is 0.05 degrees Celsius per year, than for the minimum temperature, which is 0.01 degrees Celsius per year, and the warming rate is faster in high elevation than in lowland areas. It has been observed that the maximum warming trend is highest during the pre-monsoon and winter season. In general, there is a decreasing trend in precipitation, but there is significant spatial variation in KRB. The issue of decreasing precipitation is not just for the shortage of drinking water, it is tied up with the problems of food production, land development with increasing population, and importantly, lifestyle changes. This decreasing trend of precipitation in most of the area of Terai Hills and Trans-Himalaya and increasing temperature trends in almost all areas of KRB will aggravate the situation, leading to poor quality of livelihood and towards greater vulnerability. It affects not only water and livelihood but also to different development programs. Though most precipitation stations trends were not just statistically significant, reflecting high interannual and decadal variability, the decreasing trend of precipitation, nearly constant discharge, and almost a month of time lagging in the peak discharge needs further detailed study. The KRB is mostly susceptible to drought and higher food prices. It will take longer for households in this region to recover from climatic shocks. Therefore, along with the incorporation of the local indigenous knowledge and practices, regional cooperation and synchronized collective efforts are vital to cope and adapt with this changing hydroclimatic variability in the basin.